in your textbook, do you have something that looks like and that's defining a vector like, is that the way your textbook does it? Or does it do something else?
Let me look it up real fast. Yeah, that's what it looks like.
Okay. These numbers are just coordinates that identify the vector. And so if I draw a coordinate plane and I go over 6 and up 4 and I place a dot there, if I draw a line from the origin out to that dot, then that will tell you what my vector is. So that this is the x part of the vector and this is the y part of the vector.
Alright.
So it's kind of just like the same thing that we did with complex numbers. Except for instead of being real and imaginary, it's now x and y.
Okay.
And so when you see something that looks like this, that's asking you for the size of the vector. And do you remember how to figure out what that size is?
The size of
It would be what?
The absolute value. Absolute value.
It's not an absolute value. This means magnitude, right? So do you remember how we found the magnitude of z last week?
I don't remember the magnitude. I don't remember how to get the
Okay.
magnitude.
So we're just going to use the distance formula. So your magnitude is going to be equal to your x squared plus your y squared, the square root of it. So this would be equal to 6 squared plus 4 squared. So this is 36 plus 16. And that would be the square root of 52. And so that would be the size of that vector. And then if I want to figure out what the direction of the vector is, remember last week we did tangent inverse of y over x because we wanted to try to find this angle. Because every single vector can be broken down into a right triangle. Where this side is 6 and that side is 4. And so if I want to know that angle, that means I have the adjacent side and the opposite side of the vector. So that's where the inverse tan comes from. So in my calculator I would do tangent inverse of 4 over 6. And so this would be so that would be 33 degrees. And so for every vector you have a size or a magnitude, and you also have a direction. Do you have any questions about that?
So,
Because I'm going to ask you a question to do next, because I want to make sure that you understand it.
yeah. Are you basically taking the like
I need you to speak up a little bit for me because I can't hear you.
okay it's called the tangent with the negative one. Are you
Uh-huh.
doing that the slope, just the slope of it?
That's the inverse tangent, and it's always going to give you an angle. Whenever you
Yeah.
see an inverse function, it's asking you what angle does that ratio make.
Okay. Okay. I think I understand it.
Okay, so let me give you a vector to do. Do you have a mouse there?
Yeah.
Okay. I'll do this part. Okay, can you draw that vector for me?
Yeah. So I'm just drawing.
Yeah, that's good. Now I want you to tell me what this would be equal to. Good. And now find the angle for me from there to there.
I don't know what the calculator is.
Do you know how to do that in your calculator?
Yeah, but I don't know what the calculator is right now.
Oh, okay. All right. Hold on one second. I'm trying to get some questions out of my book. Okay, 553. Okay. So here's the next step now that you know what a vector is.
Okay.
So with these vectors, what we can do is we can add and subtract them and we can multiply them.
Mhm.
So let's say we have u is equal to and v is equal to 7, 5. And I want to figure out what I want to figure out what that's equal to.
Okay.
Well, I'm going to draw these two vectors separately. Okay?
Okay.
So the little red vector is u and the blue vector is v. And I want to add those two vectors to one another.
Okay.
So there's a method graphically called tip to tail. So when I draw a vector, the arrow part is considered the tip, and the back end part without the arrow is considered the tail.
Mhm.
And so when you're adding two vectors, you take one vector, like this red one, and you place the tail of the second vector on the tip of the last vector.
Mhm.
So what I'm going to do is I'm going to take this blue vector and I'm going to move it, so I'm going to add it to the red vector. So I'm going to make a little cross right here. I wish I could actually grab this thing. I don't think I can. Not in this software. And I'm just going to take the blue vector and add it to this red vector. So I'm going to count up 5 from there. And then I'm going to count over 7 from there. And so my new resultant vector, I'm going to put in green. I probably should have done an easier one just to show you. But the resultant vector is drawn from the origin out to the very last one.
Mhm.
This is how you do it mathematically. If you want to do u plus v, the x's get added together, and then the y's get added together for each one of the vectors. So I'm going to make what's called a vector table.
Mhm.
So this is x and this is y. And I'm going to write u there and v there.
Mhm.
And the x coordinate for the u vector is 1, and the x coordinate for the v vector is 7.
Yeah.
And then the y for the u is 2, and the v is 5. I separate the x and the y's because I'm going to add them together separately.
Okay.
So that means that this would be 8, and that would be 7.
Yeah.
And so my new resultant vector I'm going to call r would be these two coordinates.
Okay.
So remember, when you're adding vectors, the x's get added together, and then the y's get added together.
Okay.
Now if I want to know the magnitude of this, then I just do the same thing that I did before. So the magnitude of r would be equal to the square root of 8 squared plus 7 squared, because that's what I did before, right?
Yeah.
And then, so that's 64 plus 49, and that's 113.
Mhm.
And then in order to find the direction, the theta, I do the exact same thing that I did before. So I'm going to take the tangent inverse of 7 over 8. That's going to be somewhere close to 45 degrees.
Mhm. Okay.
So let's see if you can follow the same process.
Mhm.
So here's your u vector. And here's your v vector. And I want to know good. And I'm just going to call this r. Can you show me? Right.
And then do I do the magnitude?
Yes, give me the magnitude. And then show me how to get the direction.
Don't tell my calculator is.
That's it.
Right.
Okay. Now, I'm going to go the other direction now, okay?
Okay.
Let's say that you're given a magnitude and a direction, and they want you to define the vector.
Okay.
So let's say that vector u, does your book put carets over that, or does it put a line over that to show this is a vector, or does it just write the letter?
It does like, let's see, one of the ones that are on there, it has that.
Okay. Okay. So it's giving you letters, and then it's saying that's a vector. Okay.
Yeah.
So let's just use that for example. Let's say that the magnitude of that is equal to 5 newtons. Does it use theta or alpha for the angle?
Um, it uses theta.
Okay. And let's say we have a theta of 60 degrees. And I want to know what are called the components for the vector. Does your book use I hats and j hats?
Yeah.
Okay. So let me show you how to get that part. Remember that every vector can be drawn from the origin. So my vector is going to look like that. This is 5 newtons, and then this angle theta is 60.
Okay.
So for every vector, I can break it into a right triangle. So that's the x part. And then this blue line would be the y part. So I'm going to do just a little bit of trig here just to review. And then if you can remember the pattern, you won't ever have to do this again. So this is the hypotenuse. This is the opposite side. And that's the adjacent side.
Yeah.
So if I do, this is theta here. If I say the cosine of theta, that's equal to the adjacent over the hypotenuse.
Yeah.
So I can solve for the adjacent side, which is the same as the x side of this triangle, right?
Yeah.
So that means that h cosine of theta is equal to a. So I just stick in the numbers. This is 5 cosine of 60. And that's going to give me the adjacent side of that triangle. So that's root 3 over 2. So this is equal to 5 root 3 over 2. And that would be I hat, or the x component of that vector.
Yeah.
Then I'm going to do the y side. So I have the sine of theta is equal to the opposite over the hypotenuse. I'm going to solve the exact same thing, but I'm solving for O. So that means that the hypotenuse times the sine of the angle is equal to the opposite side. So I do 5 sine theta, or 60, and that would be equal to 5 halves, and that's the j hat, or the y component of the vector. And so if I wanted to define the vector PQ, then it would be equal to 5 root 3 over 2 I plus 5 halves j.
Mm-hmm.
So whenever you're doing the I part or the x part, it's always cosine. Whenever you're doing the j part, it's always sine.
Okay. Right.
So that's where the I and the j's come from. It's just another way of saying x and y.
Okay. All right.
Okay, so let me give you a vector to do.
Mm-hmm.
Um, do that one for me.
Oh, wait. It just disappeared. I don't know where it went.
It said it disappeared.
Yeah, the board. Let me see.
Did it come back yet?
No.
All right, hold on one second. I'll try that again. Can you see that?
No, like I can't see the white board at all. Like the entire thing.
Can you refresh your screen? Can you hit the circle button and see if you can get it back?
Yeah. Okay. Let me go back. Sorry. Um,
I think they just did an update. That's what happened because now my screen looks different.
yeah.
Try closing the page down and then re-clicking on the link to reopen it.
Okay. Um,
Any luck?
They have land only net loans for 10 acres or less.
Oh, really? Well, at least we can get the land.
I need to figure out when I'm going to work.
Did you get me back now?
Yeah. Guys, let's see. Okay, I'm back to the high, it says.
Oh, great. Okay. Sorry that I lost you for a minute.
Right.
Okay. Um. So let's say the magnitude of OR is equal to 16 and theta is equal to 45 degrees. Can you break that vector into its components for me?
Yeah.
And you don't have a, do you have a calculator on your computer so you can do a little bit of sine stuff, sine and cosine stuff?
You really, I could pull one probably.
If you just show it to me mathematically, then I'll do the numbers for you.
Okay. Um, um,
Are you writing anything?
yeah. Isn't it right now?
No, it's not.
Oh. Yeah. Yeah, is the graph there? There should be a graph.
But you can see my OR and my theta?
Yeah. Yeah, I can.
That is really weird. You can see me, but I can't see you.
Yeah.
Okay. I'm not going to get off the call, but I'm going to refresh the page and use a different whiteboard. So give me 1 second, okay?
Okay.
Okay, I'm sharing a different link with you. Let's see if this
Okay.
one works.
Yeah. Okay. Okay. Oops.
And you're drawing again?
Yes. Just, yeah, I'm drawing. Oh, it just disappeared.
I don't see anything.
Yeah, it just disappeared.
Okay. Bear with me.
There was an equal sign I wrote, and everything else disappeared
Okay,
that I wrote.
we're gonna try something else. Okay. Okay, for this one, you're actually going to have to make a username, but it's okay. You can make it whatever you want.
Okay.
We're gonna try this whiteboard. There you are. Okay, you try to write something so I can make sure I see it.
Okay.
Okay, can you see this?
Yeah.
Okay, we're good. All right. Sorry, I'm making you do the same question over and over again.
Okay.
Okay, so all right, go ahead now. Okay, so that's equal to 11.3, by the way.
Okay. Mm.
Okay, so how do you distinguish the x from the y? What do you have to add to the number that I just wrote there?
Wait, sorry, what?
How do you distinguish the difference between the x and the y component? I wrote everything except for the letter. What letters are associated with those?
Oh, why, the letter, like the O and A?
This thing?
Oh, yeah. Right.
So now write out what the equation for the vector would be then.
Um, oh, wait. Mm, mm, sweet. Mm,
I'll help you.
oh,
Notice that there aren't any bars around it, right?
yeah.
Because that actually defines the whole vector. It gives you magnitude and direction together with the I and the J. So you don't have a bar or anything around it. There's no magnitude sign.
Okay.
Okay. So now I'm going to give you two vectors and I'm going to ask you to add them together and find the magnitude. So we're going to kind of put everything that we've learned all together in one question. You
Okay.
ready?
Yeah.
All right. So let's say PQ has a magnitude of and 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 I want to know now if you get stuck or you don't know what to do, just ask me and then I will help guide you.
Okay. So, So would this right angle just be there?
Yep.
Then would
Perfect.
the theta be 60?
And that would be 60.
Okay.
What do you know about the x component of that vector? Is it positive or negative?
Negative.
It's negative, right. And what is the y component? Is it positive or negative?
Positive.
Good.
Okay. Mm. Well, would I write 120 or 60?
Oh,
Yeah.
okay. I don't know how much information to give you. If you were to use your calculator and you would say the sine of 120, it would give you the right answer. And if you were to say the cosine of 120, it would give you the right answer. Because it would make it negative automatically.
Okay.
But if you use 60, which is inside your triangle, then you have to make the answer that you're going to get is going to be positive. Does that make sense?
Yeah.
And then you would have to make the number negative on your own.
Okay.
Is that clear? Am I saying that
Yeah.
right? Okay.
Yeah. Let's use this.
What? Right. Perfect.
Okay.
So this is going to be equal to 6. No, it's not. That's 0.88. Hold on one second.
Okay.
12 sine 60. So this is equal to 10.4. And then this one would be equal to negative 6.
Okay.
Now label the vector parts.
Okay.
I mean, with the vector notation, the I hat, J hat stuff. Which one's an I and which one's a J?
It's
Good.
okay. So these two. Oops.
I understand. It's fine. Never mind. Go ahead and fix it. You see the arrow function up at the very top?
Yeah.
You see the black arrow? Select the black arrow, and then put a box around all of it, and then hit the delete button, and it'll delete all of it, so you don't have to do it separately. There you go. Yep. Now let me ask you a question. Are you noticing a pattern yet to break up the components?
Yeah.
Can you tell me what it is?
So they're like the X and Y's are the. It's hard to see. I can't see what you wrote on the side fully, but I think it's the same X and Y's, but one's negative X.
Right. Right. One's the X is negative, but the Y's are still both positive.
Yeah.
What trig function is always the Y part of the vector?
Wait, sorry, what?
Which trig function is always the Y part of the vector?
The Y.
What trig function is always associated with Y?
The cosine.
The sine. Which trig function is always associated with the X?
Cosine.
So when you have a magnitude, if you want to figure out what the component is, all you do is just take the number for the size of the vector and multiply it by the cosine of the angle in order to find the X. All you do is take how big the vector is and multiply it by the sine of the vector to find the Y. So you don't have to do this step anymore if you don't want to, because that pattern will always be the same.
Okay.
Okay?
Yeah.
Do you see that?
Yeah.
All right, so go ahead and write the equation for the vector ST for me. Right. Now, when you add two vectors, what do you do to the X parts and the Y parts?
You add them.
You add them. So you add all of the I's together, and then you add all of the J's together. So add those two vectors together for me. You can put it on a vector table if you want. Good.
Okay.
Now I just need you to do the last step and tell me what the magnitude of that would be.
Okay. Oh.
Okay, when you're doing the magnitude,
Yeah.
you don't ever have to write these letters because you're just giving me a number.
Yeah. Oh yeah. That was like what was it? I was trying to write.
Oh, you're trying to write.
I was doing.
Oh, parentheses. Okay.
Yeah. That. Yeah.
So what's the square root of a square?
Nothing. They cancel each other.
They cancel they cancel each other out. So this is equal to.
20. Yeah.
If it's all J, choose another color and draw the direction of that vector for me.
So it's direction. It's like. It's just up and down.
It's just up and down. Good. So you get it.
Yeah.
Sweet.
Yeah. Mm-hmm.
Okay, so when I see you on Thursday, same time, right?
Yeah.
We'll do dot product and then we'll start doing conics because that's the next thing that you want me to cover, right?
Yeah.
Do you know any of the conics? How to do any of them?
Like, I sort of know some of them. Like, I know, like, some of parabolas, and, yeah. Let's see. Oh. A little bit.
Okay.
Yeah.
We'll go over it. I'm guessing you have to know like foci and directrix and vertex and the difference between all those different things, right?
Yeah.
Okay. I'll go through all four of them so you have an idea of how to get to all the stuff, whether they're giving you 2 points or they're giving you the equation.
Okay.
Do you know how to complete the square? Or do I have to teach that to you too? You do know how to do that. Okay.
Yeah, I know how to do that.
All right. I'm going to post this tomorrow morning, so if you need to go back and look over vectors, you can. Please, please, please do me a favor and try some of the homework questions to make sure that you can do them. And if there's anything that you get stuck on, we should probably go over that first.
Okay.
Okay? I'll see you in a
All right.
couple of days.
All right.
Have a good night.
You too.
All right. Bye.
It needs work. You have to put another 50 grand in it.
What's wrong with it?
I mean, it looks like it has decent bones. But I'm looking like it may need, I don't know.
Where is it?
It's over there in Holland Springs. I mean, the price is good, but they don't assume anything. Nothing.
Hold on.